Learning to develop on Android is much more than learning APIs or shortcuts. It's training your brain to think like a mobile developer. Android Fundamentals, developed with Google, tells the story of Android's history while you build a real app, exposing you to current APIs and battlefield experience that will help you think and code like a seasoned Android developer. For more information, visit udacity.com/Google.
Hi, I'm Jenny from Udacity, and I manage the Developing Android Apps training course with Google's Reto Meier, Dan Galpin, and Catherine Kwan. So today, Reto and Dan are here to tell you more about Android development and why you should be learning it by taking our class. So they're also here actually to answer your questions about Android best practices. So let's get started. Reto, tell us why that now is the time for students to be learning Android development.
I think it's a really exciting time to learn Android development right now. I mean, Android's been around for a while, so it's an existing platform with a huge user base, a large variety of devices, and just it's a platform where if you're building something for it, a lot of people are going to be able to take advantage. So it's really an opportunity to have a massive impact on the world. Especially right now, it feels to me almost a lot like it did right at the beginning in the early days. You know, we have these new platforms which are available with things like Android Wear, Android TV, Android Auto. In addition to all the platform changes, it just feels like there's a huge opportunity to be inventive and creative.
Absolutely, and and I think just to second that, like we are now also seeing a renaissance of Android developer tools. We have a really stable version of Android Studio, and it is making Android development easier than ever before. And I think, and also with what we've done in terms of the incredible work the team has done putting together new design guidelines for material design. Like I think we have the strongest design that we've ever had in Android.
Absolutely.
So I think the combination of great tools and strong design means it's a great time to jump in. You'll actually be ahead of the game because you'll be learning all of this great new stuff, which is really going to be propelling Android forward for the next several years.
Yeah, absolutely, and I think one of the other things which really makes this time unique is the fact that we've got Google Play Services now, which is a great way to make sure that you're not trying to figure out whether it's time to use these new APIs or whether you have to wait until a certain number of devices have them. Suddenly we're in a situation where everything's available basically to everyone right straight away. I think that really helps.
Cool. Okay, so we got the why covered. What about the what? What will you learn in the course that you've all made with us?
Well, you'll learn everything you need to know to be able to build your first Android app. I mean, we try and cover all of the fundamentals, all of the things which you really need to understand to be able to build not just an app on this particular form factor, but understand how mobile devices are different and the way in which having to develop for Android specifically may be a little bit different from some of the different technologies or platforms you've had to develop for in the past.
Yeah, I think the really key thing is we want to train you to think like a mobile developer. So that's really was from the whole beginning and the whole genesis of the course. But also we're teaching you how Android actually works. We're not saying here's how you use a library that glosses over this great massive bit of functionality. We're saying when you go through our course, you're going to understand how Android works. So when you actually find a problem in your code, you're going to be better equipped to learn. Not to not only fix the problem, but actually to find the answer. And I think that's kind of exciting.
Absolutely. It was one of the things which, when I was talking to people on the team about what we were trying to build and how we were going to put it together, they asked me a lot of the time, like, what is it you actually want to teach developers? Like, what is it that you're passionate about telling them? And it wasn't just how to get started as quickly as possible, because it's actually not that hard to get started, right? Like, the hello world kind of writes itself. But it was like, really fundamentally the right way of building things. How does it all work underneath the covers? What are the bits and pieces which really make the platform what it is? And so you'll see that in the course. We kind of go through that process where we're teaching people this is how you get set up, this is how you create your activity, how you create your fragments, how you put together your layouts. But then we also jump in and explain some of the background and history as to why you would do it that way, particularly where it may be a little bit counterintuitive to what you maybe experience in other platforms.
And I think the really cool thing that we do too is that we don't just give you the solution, but we actually show you how to find answers. So go to our documentation, go to these online resources, figure out this answer for yourself, and then we'll explain to you how to do it. And so I hope that by the end of this, developers feel really empowered to use all the resources that are out there on the web beyond what we have in the course to really push their application development forward.
And there's story times, so.
Yeah, absolutely. That was one of my favorite parts. It was so much fun filming those. We went all around campus to some of my favorite locations and talked about some of the history behind Android, the history behind the naming of the different releases, you know, what G-Core is or Google Play Services and how that all works. You know, some of the devices, you know, we've all kind of been involved in Android right since the very beginning, the first Android device. And so being able to go back and tell that story about, you know, what was the first device like and how did they progress and evolve over the years was a lot of fun.
Cool. You guys ready to answer some questions from students?
I think so, yeah.
Great. Okay, so let's get started here. First question. What is a recommended pattern for passing data between fragments? Put data in parent activity? Use event bus like Guava or Square Auto? That's from Warwi, Bangkok, Thailand.
Oh, it's a good question. I know you've got some thoughts on this, so why don't you start us off?
Sure. So I actually really like the tools. You know, I like Auto a lot. But in general, I feel like if you're trying to do something relatively simple, like just share data between fragments, that you're better off doing something that's very, very straightforward. You know, a lot of what it does is try to hide complexity from you. Annotations actually require the use of reflection in Android, so they're a little slow. And in general, the team says avoid reflection whenever possible. So my feeling is, yeah, it's easy to put in the activity, but if you really want to decouple things, we actually built something into the support library called Local Broadcast Manager. And that's a really, really easy way to create, you know, just broadcast messages that go between different components and have them completely decoupled. But there's nothing wrong with just using the main activity to share data.
Yeah, absolutely. And you'll see this is something which we talk about a lot. And I think we're probably going to get a couple of questions around this as well, where people are like, shouldn't we just kind of use one of these pre-existing frameworks to make life easier? This is a pattern that I'm sure a lot of people have done before, and we want to make it easier. And the problem with using those sorts of abstractions is that they generally come at a cost. And so anything which involves creating objects, reflection, anything like that is going to be less efficient than if you just did it manually. And you can kind of get away with that sort of thing if you're working on desktops or on server environments where you can just throw more CPUs at the problem. Doesn't work quite so well on a mobile device where you're really constrained in terms of performance, in terms of memory, and it's not something you can upgrade on the fly. All right? And so generally speaking, and certainly within the course, we've stayed away from using libraries, both for efficiency reasons and also because we want to make sure people understand the fundamentals without having to rely on anything else. But really, that efficiency thing can't be overstated. It's really important. And so, yeah, for something like this, where there's a really easy solution, just pass that information through the activity. You know, that's generally going to be the way that we would suggest going forward.
Cool. Okay, well, that was a good question. The next one is, what is the proper way to retain the state of a nested fragment? Example scenario, activity with nav drawer to container fragment to view pager. And that's from Alam Kanak in Bangladesh.
Well, you know, the way I look at this is that the framework works really hard to make sure that you don't have to worry about retaining state. You know, that's kind of its goal. And whenever you try to fight it and retain additional state, you might end up doing something the user doesn't expect. And so the key thing is when you actually get that you know, next on create view and on create fragment, you actually end up with a saved instance state. And if you should check to make sure that saved instance state is null when you actually go to create things. Otherwise, the platform will actually go through, create your fragments, and put them into the right state for you. Now, then you can use on saved instance state to actually save additional information which might be relevant to your application at that point. But in general, rely on the fragment manager. You know, that's what it's there for.
Absolutely.
And you know, don't try to second guess it. It's one of the things we actually talk about in the course as well. You know, is really leverage the framework to try to save state when you're dealing with any kind of UI, because otherwise you'll end up putting the user into a place that they may not understand.
Yeah, absolutely. And it's usually a pretty good hint, actually. If you're doing something and the framework isn't taking care of restoring that state for you, that's probably a sign that you're doing something a little bit unusual, and you want to be very careful about what you're doing and what's causing that to happen.
Yeah, you want to make sure that user experience is really strong.
Yeah, absolutely. You want to avoid surprising the users, basically whenever you can. It should all be predictable. You know, if they rotate the screen or switch back to your activity or anything like that, it should be like totally non-noticeable. Just, yeah, okay, that's exactly what I expected to happen.
So users do not like surprises.
Generally not.
Yeah.
Okay, so here's another one. I'm confused on when to use async task, sync adapters, or intent services for performing HTTP requests. Are there best practices for when to use one of these three options?
There are, and that's actually a really good question. We get asked this a lot. I've had some conversations with tech writers on our team trying to figure out exactly what is the right time to use each of these things. Does one replace the other? How does it all work?
Yeah.
And it's not an entirely a trivial question to answer. Basically, an async task you want to do when the process that you're doing is short-lived and is going to be entirely executed within a short period of time, within something which you can expect to finish, or if it doesn't finish, it's not a problem. So you were going to say something.
Oh yeah. So actually, it's funny. I think the async task pattern has mostly been deprecated.
Yeah.
Because the problem with async task is it isn't actually tied to the life cycle of your activity.
Yeah.
So in general, if you feel like what you're doing is saving, it's data that's only going to be used in that activity for the moment. You're not caching it to disk or anything like that, or in this case to flash. I think of everything as being a virtual disk. Then what you want to do is actually use async task loader. In the loader pattern, because the loader pattern ties that to the activity lifecycle. Oh, that makes sense. If you're going to be caching it to disk, then you want to make sure that transaction completes even if your activity goes away. Yeah. So in that way, you're going to want to use something that runs in a service. Intent service is a pretty good example of that.
In fact, the intent service is a good example where you've got a broad underlying component, a service, which is exactly what you want to be using for anything which is application context specific, something where you're trying to download data from the internet, something like that, where it has to happen whether your activity is visible and alive or not. So you really want it to complete. And an intent service is just a really neat pattern to implement that service in what is really the most common case, where you're saying, hey, go and do this, and if I ask you to do it 3 or 4 times, just queue it up in a nice sequential pattern and keep going through all of it, and when it's done, kill the service and give us that resources back.
Exactly. So intent service is really great. Again, if you're trying to keep, if you're going to be doing something where you want to use the data outside of that activity, basically. If you're only using it in the activity, you can use something like an async task loader, intent service if you're using it outside of the activity, like if you're, again, caching it for future use. And then, when do you use a sync adapter? That's the real question.
Yes.
And the reason you use a sync adapter is a couple things. One is if you're going to be literally synchronizing data. So if you're going to be modifying data within your app and you want to actually synchronize that data up to a server. Yeah. So the sync adapter is actually really, really good at managing those state changes and making sure that you actually have that background service that does all of that. But the other thing it's useful for is if you want to schedule activity in the future. And and what's great about a sync adapter is you can actually make sure that it gets scheduled even after a boot. It really handles all that mechanism for you. And in KitKat, we've made it even more powerful by allowing a sync adapter to actually be scheduled on variable time. And so by automatically we give you a little bit of jitter on your sync adapter, but then you can use essentially the same pattern we have with inexact repeating alarms. Yes. And we support that similar mechanism within sync adapters to make that really, really powerful and really reduce the battery drain of your app.
Yeah, that's right. And the inexact repeating alarms which you mentioned, that's kind of the old way of doing things, right? Yeah. Where you would basically set up some sort of polling mechanism for anything which you wanted to download. You'd set up an alarm and say, I want this to sync every hour or every 10 hours, once a day, whatever it is. And you'd make it inexact repeating so that it wasn't always triggering at this set frequency.
Exactly.
You'd be able to combine a few of these syncs together so that you're being a little bit more efficient. The beauty of the sync adapter is that you can switch that polling mechanism around and suddenly it becomes server push-based. So you're able to send a message from your server, something like Google Cloud Messaging, anything like that, and then have that trigger off your sync adapter rather than having it sort of happen on this ongoing basis.
Yeah, absolutely. So I think there's multiple reasons why you'd want to use it. The other thing that's nice about sync adapters is they're really, really beautifully tied into the content provider mechanism.
No, absolutely.
And so if you're already, so it's like, why do you build a content provider? Well, because you've got this fantastic sync adapter that you get to use that actually does all this additional work for you to try to actually schedule tasks in a reasonable way. And so again, and it's beautiful. Yeah, using it with GCM is absolutely something that people should do. Don't, if anything, don't do what we did in Sunshine. Don't pull. And we'll, hopefully we'll actually get into using GCM in some future lessons.
No, absolutely. And I think that's one of the big challenges. It's like a lot of this stuff, it kind of piles on itself, right? The easiest way is like, well, I want to create a new thread, and async task is a great way to start a new thread without having to actually do all the thread management. And so I can do that and download the data, and I can stick it in. I won't even bother putting it into a database. I'll just put it into an array. Yeah. And that's a really quick way to be able to get an app to do something. But you sort of run up against those limitations really, really quickly. And suddenly you're like, well, I should probably store the data, and if I'm doing that, do I need a content provider? Well, Probably not, except if you want to use sync adapters, and you probably don't need that unless you want to do Google Cloud Messaging to do the sync. But that's the right way to do it, right? Because ultimately, the difference between the simple and the more complex version is an app which is going to be significantly more efficient. It's going to drain a lot less battery. It's going to be much better user experience. And it's worth thinking about that right at the beginning when you're kind of architecting your app.
Yeah, it's so much better if you actually bring up, like in the case of Sunshine, a weather app that's showing you the current weather rather than the weather, rather than either nothing in the case if you're not storing it at all, or the weather from a week ago was the last time it actually hit the server. So we can make sure that it always has a really great user experience whenever they launch it, or if they launch it while they're on a train, they don't have service.
Well, this is how I always used to test apps when I was living back in London. I would do that as part of my morning commute, and the underground would go underground, and I'd have no connectivity, and then as I'm loading up apps and they do nothing, it's like, okay, they're making it.
Cross that one off my list.
So you guys gave a couple good examples for using sync adapters. Are there examples for where a student might use async task or intent services, like a real life app?
Sure. I mean, realistically, I think where most people are asking the question, it's around data synchronization. It's like, when should I use each of these to sync data from the internet, something like that. And the answer to that is basically always use sync adapter. It's more work, but it's more flexible. It's going to get you the best. The other two things you can use, but for other examples. And it's funny, finding specific examples where they're the right answer is becoming harder and harder, really, right?
Yeah, I mean, honestly, there are so few places where you want to use async task today. Again, using async task loader is occasionally useful. But well,
that used to be the big thing, right?
Yeah.
You'd use an async task in order to load data from a content provider or something like that to put it into your UI. And when loaders came along, suddenly that wasn't a use case anymore.
Yeah, we kind of eliminated I would say most of the primary uses for async task. I mean, mostly I use async task when I'm troubleshooting things because it's a really simple pattern to do that with. It's simpler than loaders, But at the same time, you're better off using one of the other patterns almost always today. Yeah.
And intent services?
Intent services, again, it used to be kind of the go-to for doing data downloads in the background. In fact, your sync adapter is going to have a service implementation in and of itself. It's just more specialized. So it's really, if you're trying to do something else like that, where you have a sequential set of things which need to happen in the background, not within the activity, but isn't related to data download, which actually gets to be a pretty small number of things at that point.
There's a reason why we actually implemented all of this in Sunshine. And Sunshine's a pretty simple app, but we actually implemented what we think is really a best data practice for the most part. We couldn't do GCM because we don't actually control the server backend, but for the rest of it, we actually really tried to make sure the student actually gets to see, here's what you really should be doing in a real app.
Okay, cool. All right, moving on. Next question is, currently developing my first Android app. Woo! I decided to directly jump into L's developer preview. Brave students.
Excellent.
Yeah, that's right.
What should I do to respect as much as possible Google's material design standards while still being compatible with interior OS versions?
Great use of that word.
Jean-Philippe, Quebec.
Well, you're in an interesting transitional point right now because
that's a really polite way of saying that it's still in beta and things are going to change while you're learning it. So that's exciting.
So right now, for example, you can use our Action Bar Compat stuff, and we actually show you how to style Action Bar Compat in the Sunshine app to some degree. We don't do a complete in-depth styling of it. It's a little complicated still. So, but we actually achieve a lot of material design in Sunshine by doing just a couple of really simple things. Some of it's just the artwork we chose. Now, again, when you get into the more complicated part of material design, like you want to use some of the new animation practices, the way to do those is a really good pattern for doing those is actually to look at what we did in the Google I/O app this year. We really did a lot of little clever things to add material design into an existing app. It's a much more complicated example than Sunshine. I mean, it would have taken us 6 months of sessions to get through how to build something like that. And but it's a really great reference if you're trying to build a material design app and you're trying to understand how to bring that into your existing apps. That being said, we want to make that easier, and we are looking to add more tools to allow you to build material design into your older Android apps as well.
Yeah, absolutely. I think one of the questions you kind of have to ask yourself when you're doing this is, do you want to try and create a single app which kind of looks and works the same across as many versions as possible, or do you want to almost present a different kind of experience for something which is material design versus sort of old versions of Android? And there's, I think, positives and negatives to both. One of the advantages if you're treating your material design version separate is that you can kind of go all in.
Yeah.
It's like, I'm going to do all the things. I'm going to make sure that it's completely material design looking, use all of the same assets, all of the design methodologies and philosophies behind it, without having to worry about how do I implement that on pre-L stuff.
Exactly. And I think that, my feeling is that you should kind of go halfway on pre-L. Like, don't try to implement crazy animations on pre-L. You're going to spend a lot of time with that. Take advantage of those features in L. We've got fantastic new animation features there. But when it comes to things like assets and choice of color, you can really make your app feel very material. And that's what we did in Sunshine. We did kind of the absolute minimum, I would say, to the app to make it feel like it was echoing material design without adding a lot of complexity. And I think what's great is that the team is going to make that even easier going forward.
Exactly.
But again, there's so many cool things you can do with L, with transitions and with animations and with using actual hardware depth, and definitely enjoy that. It's really fun.
Yeah, absolutely. And I think that's really what it comes down to. It's like utilizing the APIs where they're new and shiny and awesome, but then using that kind of design language, which is something which you can port backwards just by use of themes and colors and assets and that sort of thing.
Yeah, it makes prettier looking apps. I think. They've done a really lovely job of coming up with something that I think is going to be a great design language going forward.
Okay. So this next question comes from Budius in Berlin. All examples of KitKat transitions show view-to-view transition, and on L, make scene transition animation, activity-to-activity transition. What's the best practice for using transitions with fragment transactions?
So I saw this question earlier and I thought, I can't remember exactly what the things are, so I'll look it up. And I looked it up on Stack Overflow, and there was this great, long, detailed answer, and I had written it. So that was a plus. So it is possible, and the long answer is on Stack Overflow, so you can check it out. But there's animation transitions built into the Fragment API. So if you create a fragment transition, you can specify an incoming and outgoing animation to apply to that transition. And it will apply, basically as you show or hide each fragment, it will apply that animation in. So you can slide fragments in and slide them out, or fade them in, fade them out, all that sort of stuff. And there's a bunch of built-in animations you can use, or you can build your own using, I think it's the Object Animator tag in XML. Specify your own interpolator or use one of the built-in ones and basically make it do whatever you want to do. So that's the equivalent for fragments.
Yeah, and it'll, if you're using the support library, you're going to get those animations only going forward on Ice Cream Sandwich and above devices that can support the animations. But it'll work. You can specify them, they just won't actually show up on Gingerbread.
Exactly. And so a lot of these things you can do to kind of get that animation look and feel on earlier versions of Android. So you're kind of using the activity transitions on L, you're using the fragment transitions for Ice Cream Sandwich and above. Before that, you're a little bit out of luck. We didn't have great animation support pre-Ice Cream Sandwich, unfortunately.
Yeah, it's funny. I actually used fragment transitions a lot when I was first programming, because I actually avoid using multiple activities a lot of times and just take advantage of the fragment stack. And so it's interesting. The activity transitions I thought were really exciting when they came out, but I'm like, well, actually, I do so many fragment ones already. I almost don't really need them in a lot of cases. But it's going to be fun. We're going to see some really, really cool stuff in apps with those activity transitions.
No, absolutely.
And so if for the longer in-depth written answer, they should Google for...
Yes, it was, yes.
Reto Meier.
Yeah.
Does that happen to you a lot? Like when you look up something and you're like, oh, here's an answer, and then, oh, I wrote this.
Disturbingly so. I'm like, oh, this looks long and It's one of the joys of having been working on Android for a while. It's like you'll have researched all of these because someone will have asked us, we're trying to figure something out, and then you'll share it on Stack Overflow and then completely forget about it.
Yeah,
much like exams.
The joy is when you discover something that you wrote. You're like, oh, that's pretty good, actually. That still makes sense. But
the less joy is when you look up in your answer going, this is terrible. It's completely wrong. Who wrote this? Scroll. Never mind.
Okay, so our next question, again, comes from Bangkok, Thailand. And the question is, what's the best pattern to handling screen rotation?
I think the best pattern for handling screen rotation is don't handle screen rotation.
I was looked at this question, I'm like, okay, I'm not sure what was meant here, I have to admit. So I'll say a couple things. One is that in Sunshine, we handle screen rotation from a layout and design perspective in two ways. We handle it in the main list view by simply trying to make sure that that main list view could actually scale out well to different dimensions and sizes. And you want to do that anyways. You want to make sure that you can handle a fairly narrow list and a fairly wide list. We could have done a better job had we actually had a separate layout for both.
Yeah.
And if you look at the informational view, we actually do that in Sunshine. We have a separate layout for ports. So if you're talking about handling it that way, in that sense,
accommodate screen
how do you
rotation.
accommodate screen rotations? Because handle is like it's a little vague. But yeah, in terms of handling it directly, yes, you can handle it. You can, and it's great that Android gives you. And you'll see a lot of games that actually handle it directly. And I work with a lot of game developers, and so I do see that. But in general. Rely on the framework. It's really good at handling
exactly.
it.
The framework does a really good job here, where it basically, as soon as you rotate the screen, it'll tear it all down and build it all back up. And I know when you started looking at it the first time, it's like, why would you kill all my stuff? I want the same thing.
Yeah.
But it's because you can theoretically have a completely different layout, completely different strings. Particularly in some languages.
Yeah, absolutely.
If you're supporting German, then you may need to have shorter strings for the portrait version of things rather than landscape, right? Because it's a lengthy language.
Yeah, absolutely. And I think early on, back when I first started doing Android, I was really, really tempted to put in all of those handle hardware changes, including screen rotation, because it seems like it makes everything easy.
Yeah.
And then you realize, oh, it's just not behaving correctly anymore. And so it's in most cases it's best to let the platform tear down your activity and recreate it, and that gives you a huge amount of flexibility when you're actually doing, especially if you're doing what I like to do, which is actually have a separate layout for portrait and landscape.
Yeah, and this is particularly in L. There's some really cool new features which help make sure that those transitions look good, and it's all handled as well as it can be, which is fantastic.
Absolutely, yeah. I'm glad they put that time in.
Yeah, no, absolutely. So basically, the answer is if you're dealing with layouts and views, sort of a conventional user interface, then you should let the framework handle those rotations for you. If you're building something where you're completely designing your own screen in OpenGL or like a game or anything like that, then it probably makes sense to handle it yourself rather than lose all of that context and have to build it back up.
Yeah, and I always recommend is to make sure that you don't force the user into like landscape only in one direction. Like make sure that if you are, let's say, landscape only, make sure you can always handle reverse landscape, and same thing with portrait and reverse portrait. It's just nice, unless the app you're building is going to be one where you expect someone to have to shake it around like this. In which case, okay, I can understand that. A lot of things that are using lots of accelerometer and gyro.
Yeah.
Well, we have one last question.
Okay.
Exciting.
So Nathan in California asks, managing your app's memory warns us to, quote, be careful with code abstractions and to, quote, strictly avoid using enums, unquote. Do you think it's better to remove abstractions after measuring memory usage, or to design initially with no abstractions where possible?
Okay, so I guess there's a couple of questions within that question.
Sure.
And so I'm going to ask a couple of the implied questions first,
Okay.
and then kind of get to the end. A lot of people ask us this, like, is it worth avoiding abstractions, not using enums? Because it makes your life a little harder, right? As a developer, we create abstractions and use things like enums for a reason. It makes life easier. It makes code more readable, makes it easier for us to understand what's going on, to be able to black box some of the complexity away and say, okay, that's getting dealt with over here. We have that nice abstraction layer. Everything's clean where we are now. And it's not a bad idea. It's not a bad thing, except that the devices that we're running on are really small, and the processors are not that powerful, and the memory is pretty limited. So everything's slower, everything's more costly. And so every abstraction layer that you put in is just more time being spent on something that isn't making sure that your screen is being refreshed, that everything's smooth.
I think the word strict here is the case. Like, do we strictly say not to use enum? No. But an enum in Java is a little expensive. It creates a class, first of all, which extra classes are a little bit pricey. And the thing is, we can't optimize out enums the way we optimize out constant integers. Yeah. So those turn into very, very small code. Enums actually produce quite a lot of code by comparison to just using constant static final integers. Definitely. Don't not use them. I'm not going to say never use them. I'm not going to say if there's a place where having that abstraction really helps. If you have a big team and you're trying to have a whole bunch of people communicating, maybe there's a place for one enum somewhere. But the other thing I will point out...
Is there an upper limit you'll allow, like 2 enums?
Yeah. But the other thing to note, if you are using enums, be very careful with your ProGuard settings, because you have to make sure that your enums don't get optimized out. They can, and in which case your code won't run anymore. And so you do have to make sure that there's a couple of flags you have to put into ProGuard to make sure that you're not actually destroying your enums.
Yeah, and this, I guess this kind of leads naturally into the second part of the question, which is, should you design it without these abstractions in mind, or do it first and then figure out which abstractions can we take out without things getting too slow? And I don't know about Dan, but for me the answer there is pretty straightforward. It's design it to be as efficient as possible right from the word go. Avoid the abstractions, avoid the enums, and then you're kind of approaching things from a different perspective. You're kind of thinking, do I really need this? Right? Rather than which of these can I pull out, you're thinking, okay, I need to use an enum here because otherwise it's going to be too hard to read. Or I need to add this abstraction layer, otherwise it's just no one but me is going to be able to understand this code. But you're doing it that way rather than having this like removing abstraction layers from your code, like that's not fun.
Yeah, when I used to build databases on Android, I used to always use annotations. And I used to use an annotation, and I used to use reflection, and I would go through all these database classes, and I would use it to actually build and construct my databases. And it was really, really fun to do it that way. I mean, really, really fun. And then I would
cover the fact that you find databases more fun than the average person.
And then I would show someone the code, and they would be like, what is this code doing? There's this abstraction layer sitting on top of it that's doing all the work, and people would just scratch their head, and it was so much harder for someone else to go through and maintain what I was doing. So you have to be really, really careful when you use abstraction layers, because you don't want to make it so that no one else can ever touch your code but you. I mean, it's good for job security, I guess, but but also, so you have to look at it. It makes the code often runs more slowly. It makes it take more memory, and it might just make it harder to understand what's going on. So be very careful when you choose these abstractions, is I guess the answer.
Yeah, and you'll see a lot of this sort of stuff where a lot of the suggestions in how to make your apps better are around things like it feels almost like micro optimization. Like, don't use enums. Like, how expensive can they possibly be? And in truth, these days, if you're talking about the L release, a lot of the compiler optimizations and things that we have, or the runtime optimizations, more usefully, mean that it's not that big a deal. But it's enough of a deal. It's still like we're that concerned that we're worrying about things like enums. It tells you a lot about how much you have to take performance and optimization and efficiency into account when you're building things for the mobile platforms.
And you have to remember that in general, the Java compiler is really, really bad at optimizing things. Its goal is to actually optimize things almost not at all, and to rely on the VM to do the optimization for us. And so things that seem like, oh, these are easy compiler optimizations, like for example, if you have a single test in the middle of your loop that looks like it should only happen once, it turns out that test is going to happen every single time the loop is run. And so it's very, very easy for you as a developer to make that optimization. And enums are the same kind of thing. It's that if you're running a tight loop, and that tight loop is a state machine, and that state machine is built on an enum, it's going to run much more slowly than if you actually just have constant values in it. And so you might as well just use the constant values.
Yeah, it's generally going to be much easier to design it from that perspective rather than going back around and saying, ooh, because of this loop, I now need to remove all of the enums.
Yeah, exactly.
Yeah.
Well, that is it for our questions. So thank you, Reto and Dan, for being here and answering some of the students' top questions. And thank you to the students and developers. If you guys liked what you saw here, you're going to love the course. Check it out, udacity.com/Google. And you can find the Developing Android Apps course, as well as a bunch of other great courses we've made with Google.
Thank you.
That's it.
Thank you.
Thank you.